Hello everyone, my name is Zach, and I'm here to teach you guys about the coding array. Now, the coding array is an Arduino that has been pre-wired to a bunch of different components. That way you don't have to worry about circuitry, and if anything goes wrong, you know what the problem is with your programming and not with the wiring job you did. This makes it a great device for beginners to use to learn programming on an Arduino. We have the coding array right here in front of me. Now, when you open up the coding array box, you will be greeted with a bucket of wiring and the coding array itself. Now, the Arduino part of the coding array is this one board right here that I am tracing with my finger. Now, this right here is the board, and everything else are all the different components. When you would be assembling these in a robot, chances are these components would be scattered about your robot, and you would use them to perform different tasks. Now, the first thing you're going to want to do is take the included wire, and you're going to want to go ahead and plug it in to your computer. Like so. You'll notice it'll turn on, and it will immediately start to run whatever program you had beforehand. For mine, it's going to display the temperature and humidity. If you have a new coding array, the screen will be blank and may not even turn on. What you're going to need to do this project is you're going to need to go ahead and get the Arduino Ide. An IDE is an integrated development environment, and this is basically where you'll be writing all your code. Alright, once Arduino loads up for you, you will be greeted here with a blank project. Like so. When you open this up, you're going to need to have the following things ready to go. If you go to Tools, you should make sure your port is selected on your Arduino and that your board says that you are on the Arduino Uno, as that is the one built into the coding array. On side of Sketch, you want to make sure you've included the right libraries, which you will need to download as follows. The three libraries that you will need to go ahead and get. Let's go to Installed Libraries. I've already got these ones ready to go. It is the Adafruit Unified Sensor Library by Adafruit, the Dht Sensor Library by Adafruit, and the Liquid Crystal I2C by Frank de Brabander. And once you have those three libraries, you are ready to go program your coding array. Now, you will need to go ahead and we're going to start by just making a light turn on and off. To do this, if you look at the coding array, you'll notice that everything here is labeled with numbers. Our little light there says D13. Now this means that it is hooked up to the 13th pin on our Arduino. However, it is actually hooked up through the blue board itself, and there's no wiring needed. We want this pin to be set as an output because our light is going to be outputting numbers, and it is not actually going to be inputting any information. So, back on our IDE, we want to go ahead and we want to set the pin mode on pin 13 to output. And you need to end all of your lines with a semicolon. This is inside the setup loop, which means it'll only run once when you first begin to write your code, and your loop function will go ahead and run every single time that it's running. So this is where you'd write things that you want to constantly happen. Within our things that constantly happen, we want to make our light blink. Now, if you look back at the board, you will notice here that everything on this side is labeled as digital. Now, digital means that its information is transmitted just using ones and zeros. Things on this side are labeled as analog, which means they take a range of values that can be a decimal, whereas this would be a 0, and this would go all the way to a 1. And as far as wiring is concerned, this side is using a patterns of the wiring has electricity and doesn't have electricity to send their signal, and the analog here is basically using a range. The more electricity, the higher the value. So we're going to be going ahead and we're going to be writing using the digital side of things to control our light. To do this, you simply use digital write, and we need to go ahead and set our pin. Is going to be pin 13. And we want to write it high, which means high stands for basically it's going to have electricity running through the wire. And then we're going to use the delay function here. And what delay is going to do is that's acting kind of as a wait. We're going to wait 1,000, which is the same as 1 second, because this is in milliseconds. And now what we're going to go ahead and do is now that we've waited for 1 second, we're going to do a digital write spell that right, to pin 13, and we're going to have this one as low. And that's going to turn off the light. And then we can do one more delay, for another second. And that is going to be our program. And because this loops, every time it gets to the end, it immediately jumps back up. So this is just going to be turning on, wait a second, off, wait a second, on, off. And you want to go ahead and hit this upload button. The first time you do this, it will ask you to save your file, and we're just going to go ahead and call it the default name. Hit save. You'll notice it's compiling the sketch. And then once it's done compiling, it will actually upload it. Once it's uploaded, you will notice now our LED here is blinking once every second. Our code was a success. Now, a program without any inputs is just a movie, and a program without any outputs is fairly pointless, because even if it calculates the solution to world hunger, it needs to be able to display that to the user. We have our output, our blinking light, so we need some form of input. Now, for our input, we're going to be using a button, which is hooked up on pin number 8. So we have to go ahead and also set the pin mode. So pin 8 is now set as an input, and what we're going to go ahead and do is we're going to set it to your light turns on when the button is pushed. So probably the best way you can understand is this is just going to say if your digital read. Now, whereas we were writing to the LED, we're going to read the button value of pin 8. We're going to check if it's high, which means we're going to see if the button's been pressed. So if the button's been pressed, we're going to go ahead and we're going to do our digital write high, and which functions exactly how you'd want it to. Now, you'll notice here that we're using 2 equal signs rather than 1. 2 equal signs is a comparison. It's going to compare high and digital read 8 to see if they're the same thing. If they are the same thing, that means the button has been pushed, and we can go and turn on the light. This is going to be our if statement. Now we need what's called an else statement, which means if that first one returns false. If you are not pushing the button, we're going to go ahead and write it low. Go ahead and upload and compile your sketch. And when you look on the board here, now that it's uploaded, whenever I push the button, the light turns on. Push, 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 push. There we go. Now, this works, but, I mean, it's kind of messy. You know, if you write out a really big program, you're not going to know what the 8s and the 13s and all that mean. So you can go ahead and declare what's called a variable. And a variable is just kind of like a container that stores an information, and then you basically put a label on the container, and you can refer to the container by that label. You have to first declare what's inside of your container. We're using an integer, which is just a whole number that can either be positive or negative. And this integer is going to contain the pin for the LED. So this is going to be the LED pin. All right? And that is basically the label we are putting on the jar. Now we have to fill it. We're going to fill this with the number 13. And now, whenever we want to use the number 13, we can simply replace it with LED pin. And now it makes a lot more sense once you have a big piece of code, and you can simply look at digital write LED pin low, and you'll simply know that just means to turn the light off. This also makes it easier because let's say you unplug the LED on your Arduino and plug it into a different pin. You can just change it by changing one number. We're going to do the same thing for the button. The button pin is set to 8, and we can go ahead and put that anywhere we've talked about the button, which is just there and there. Now that our code has some variables in it, we're going to go and we're going to kind of simplify the code down. What you'll notice in our loop is that our if statement, checking if it's high, and then your else is setting it low. So what you'll notice is that the button state is always the same as the LED state. When this is high, then the light is high. When the button is low, then the light is low. And therefore, they're always going to be the same. And all we're doing is setting the LED to whatever the button is. And we can just say that. We can just set the LED to whatever the button is. And we can get rid of all of this. All right. This is simply telling us to write our LED, and we need to tell it what we want to write it. but we don't want to just write it high or low. We want to write it the value of the button. So we simply paste in digital read button pin, which is just the value of the button. And this is a single line. It's a lot more concise than what we had beforehand. See, now with our coding array here, if I push the button, the light turns on, the same way it did beforehand. All right. So we're going to go ahead and we're going to talk about, we're going to use the servo motor and the potentiometer. These are two different components on our Arduino coding array board here. And while one of them is digital, it's going to use the same format we've been using. The other one, the potentiometer, is part of the analog side of the board, meaning we're going to have to do things slightly differently. We can actually get rid of a lot of the code we have here. We don't need the LED or the buttons anymore. We don't need to set them to input or output. Heck, we can pretty much erase everything and go back just to our setup and loop, which is how we started. Now, you could do everything, and you could do all your calculations for your servo motor and tell it to, send the signals, the digital signals at the right time. But, I mean, servos are fairly common, and someone in the past has already done that, and they compiled it into a nice thing called a library. And a library is just another program file that we can then basically use within ours. And the way to do that is you use #include, or #, if you would rather call it that. We use servo.h. Now, a .h is just a header file, and this is just basically the name of a file, the same thing as like a .png or a .jpeg. This is a .h. And we're basically telling it to take that .h file and pretty much copy and paste it right into where our include line is. It's not 100% how it works, but that's probably the best way to think about it. So now we can access everything that was used within the servo file. Now that we have access to the servo file, we're going to go ahead and we're going to define our variables the same way we did beforehand. This time we're going to do an int, and this is going to be the potentiometer's pin rather than like the LED's pin, and this is set to A0. And if you look on the board, you'll notice the potentiometer, which is our yellow sliding knob here, its pin is set to A0, which just means analog. And so we have our analog pin, and we're also going to go ahead and we're going to set the potentiometer's value. It's just going to start off at 0. So this value is where we're going to be storing whatever the input is from our potentiometer. And with inside of our setup here, we're just going to go ahead and we're going to say new servo dot attach to pin 3. And pin 3 is the pin that our servo motor is on. We could have just went ahead and put this in a variable and called it like servo pin, but for the purpose of this, we're only using it once, and that is all. So new servo is actually going to be the variable we created. We actually have to create that up here. And similarly to how we had our pins as type integer, our servo is type servo. And we're going to go ahead and call that new servo, and which is the exact name I used down here. We create a new servo, and we're going to attach it to pin number 3. Once this is all set up, we can go inside of our main loop, and we can set this up. We're going to set the potentiometer's value is going to be equal to whatever we actually end up reading from the potentiometer. That's why it's the value. And similarly to how the button we did a digital read, now we're going to do an analog read. And we're going to read it from the potentiometer pin. And now we have access to all of the values from the potentiometer, and we simply access that by calling a potentiometer value. So we're going to do the angle by using the built-in map function in Arduino. So the angle is going to be equal to a map of the potentiometer value. And I'm simply going to type in some numbers here, and I'll go back in a second and explain what they mean. All right, so what you'll notice is I went ahead and we have our value, and we have 0, 1023, 0, 180. And what mapping does is it takes your value, whatever this is, and it's going to map it from the first two to the second two. The potentiometer reads a value of 0 when it is all the way over here, and a value of 1023 when it is all the way over here. That is the range of the value. And the range of our servo motor is from 0 degrees to 180 degrees, which is all the way over there. And we're going to go ahead, we're just basically taking the lower bounds in our program here, and we're kind of just lining them up. We've lined up the 0 with the 0, and whereas we want full on the potentiometer to be the same as full on the servo, we're mapping the 1023 to the 180. And this basically constrains our, this just turns our potentiometer value into an angle. Once we have it as an angle, it is as simple as writing the angle to our servo. We called our servo new servo. And we're going to do a dot write, and we're going to write the angle to it. And we're going to add a slight delay of 15 milliseconds, just to give the time for the servo to, actually start swiveling around. We can go ahead and upload this. And you'll notice it is now ready to go. As I move the slider from each side, it goes from 0 degrees, and if you watch the arm, it starts there, and it goes all the way around 180. And now our servo is ready to go. Once you look back at the code here, we're actually going to be removing the servo part of this, but we want to keep the potentiometer part. So we can get rid of our servo and our new servo and our include servo, and we can get rid of our new servo attach and converting it to an angle and all of that. All we really need to keep is the potentiometer pin and value and the assigning of the value from our analog read. This time we're going to include two different libraries. We're going to do an include. This is going to use the liquid crystal I2C. And this is one of the ones that I told you to go ahead and include at the beginning of this tutorial. And we're going to go and we're also going to include wire. All right, now that we've included our two libraries, we're going to go ahead and we're going to set it up. Similarly to how we created a variable of type servo, we're actually going to create a variable of type liquid crystal I2C, and we're going to call it LCD. And we're going to go ahead and we have to assign some different properties about this. First thing it needs is the address of our LCD display, which for this one happens to be 0x27. And you'll have to figure out which it is for yours. I'm not going to go through how to find it right now, but this is just the I2C address. And we're also going to go and we're going to include how many like rows and columns it has. So it is a 16 by 2. Now that it is set up, we can go ahead and enter our setup function, and we just have to set up everything with our LCD. So an LCD is like a little screen where you can go ahead and we're going to use it to type out letters and numbers and whatever it is we need to type out. And this is actually earlier where I was displaying the temperature and the humidity. One thing you'll actually notice is that it's still displaying the temperature and humidity, even though it's not actually changing with the real temperature and humidity. This is because we never cleared the screen, so it's just going to leave whatever the last thing we told it to write up there until we either tell it to clear, we write over it, or we just go ahead and we unplug the whole thing. And we don't want that. We want to get rid of whatever was there before. So we're going to go ahead and we're going to set it up, and we're going to also clear it. So we need to do an init, which initializes it and gets it all ready. We're also going to turn on the backlight, that blue light you saw. You can also go ahead and just say no backlight if you would rather have without it, like this, no backlight. But we want it on. And we're going to also go ahead and we're going to do the clearing I was just talking about. And you can go ahead and actually, we're going to go and just set our cursor. So this is how you determine where you want to write what you're about to type out. Is you're going to go ahead and set a cursor position. And do you remember how we had a 16 by 2? That's exactly what we're going to go ahead and use. So we're going to just start out at 0, 0, which is just the top corner. And And we're going to go ahead, and now that we've got our cursor set to the right location, we're going to go ahead and do an lcd.print. And I'm just going to say, hello world. There we go. And if I wanted to go ahead and set something on the second line, we could just copy this. But this time it would be at 0, 1, because this is on the second row. And I'm just going to say, from Zach. That is my name. And you can put whatever your name is if you're following along with this. Oh, I forgot a semicolon right here. That is actually a good reminder. You should always have a semicolon after each of your lines. The ones that don't end it with this little squiggly bracket anyway. The rest of them should have the semicolon. Now if we were to go ahead and try to compile this, and we go ahead and take a look back at our coding array here, you'll notice it now says hello world from Zach, which is exactly what we told it to say. I'm actually going to go ahead and re-upload it so you can see it clearing, and it'll turn it on. See, it clears, it turns it on, and initializes it, and it gets it all set up, and then it prints out the words exactly like we told it to do. Now, this isn't very useful since it's just printing out some pre-made text that we told it to write. So we're actually going to have it print out something useful. We're going to print out the potentiometer value, which is why I said to leave it in. We're actually going to just remove this, and we're instead just going to type out potentiometer here. Potentiometer. And once we go ahead and we've written that out, we don't actually need that little colon there at the end. We're just going to write potentiometer. And within our loop, we're just going to go ahead and we're going to set our cursor. We're going to set it to the second row. And we're going to go ahead and we're going to do an lcd.print. And we're going to do something called casting. So if I were to just immediately say potentiometer value, it would give me an error because this is type integer, like we set up here, but printing wants a word, which is called in programming, it's called a string. So you can basically cast it, which means make it something else, by making it a string, simply by saying string in front of it in parentheses. If we were to go ahead and redo this now, and we take a look back at our coding array, you'll see it clears. Now it says potentiometer 1023, and as I kind of scroll through them, it eventually goes back to 0. But you'll notice that's not 0, that says 523. And remember how I was saying before why our temperature wasn't clearing because we never wrote over it? This, from our 1023, it left a 3 on the end, and then as soon as we went under 1,000, we're changing everything that's not, because that place the value no longer exists. Now we're in the 700s, but we never wrote over top of that 8, so it's still there. Same thing with that 2. And if I bring this all the way down to 0, if I kind of wave around a little bit more, while as we are actually changing that 0 there, this 3 and this 2 are just left over. So what we're going to go ahead and do is we're just going to add some spaces in there. So we can just go ahead and say plus, because it's a word, and you can simply add words together to make them longer, and a couple space bars. And these space bars will just write over whatever it was we had before. Go ahead and upload, and you'll notice now it works exactly how you would expect it to, with it actually dropping down to saying 0 all the way through 1023. So that is how you would use the display to talk about different values. Our next thing we're going to look at is this ultrasonic sensor, and this you can use to find the distance to things, kind of like how a bat would with echolocation. You kind of bounce out a beam and then record how long it takes to get back. And we're going to keep the LCD part of it because we want to print out whatever we find to the display, but we no longer need the potentiometer here. This part's not really needed. Instead here we're just going to print out distance instead of potentiometer. And then we have to get everything set up with our ultrasonic sensor. Now, the ultrasonic sensor actually has 2 different pins on it rather than one like everything else. One of them is an input and one of them is an output. One of them is where you tell it to start sending the signal, and then the other one is where you get back how long it took. And so within our setup here, we're going to set some more pin modes. So pin number 5 is our output pin. And our output pin, this is where we're actually going to be like telling it to start sending the signal. And then pin number 4 is going to be our input. This is where our like result is going to return. And within our loop here, we're going to go ahead and we're going to make some more variables. So similarly to how we could do an integer, I talked about strings being words. There's also one called a float. Now a float is just a decimal number. And our float here, we're going to make 2 of them. We're going to make a float called distance. And we're going to make a float called duration. I'm actually not going to capitalize those. We're going to leave them lowercase. Distance and duration. And we're going to do the digital write, the same thing we did back at the beginning with our LED, our little light. We're going to do a digital write to pin 5, which was our output pin, similarly to how an LED was an output. We're going to write that high. We're just going to basically tell it to start sending the signal. And we don't want it to, we barely want it to send out a signal. We want it to very, very briefly send out a signal. So we're going to do a delay, but we don't even just want a normal delay. We want to delay microseconds, which is even less. And we're only going to delay 15, or actually no, just 10 microseconds before we immediately go ahead and we do a digital write low to stop sending the signal. It's going to be like a very short like pulse of electricity that we're sending through. And then we're going to go ahead and we're going to figure out the distance. So we're going to find the duration of it is the pulsion from pin 4. And we want the duration that it's high. All right? And we can go ahead and we can do our distance calculation based on that duration. Now, there is some math going on here that it explains exactly why this calculation is the way it is, but we don't really need to worry about that for right now. Just know that this math equation here goes ahead and gives us the distance in centimeters. All right, so what we're going to do is we're going to do 340 times the duration, make that a float, and we're going to divide it by 10,000. And then take all of this and divide it by 2. So now that we have our distance, we're going to go ahead and we're just going to do an LCD printing like we did before. So we're going to do an LCD.setCursor, but we're going to set it to the second line here by putting in a 1. And we're just going to go ahead and we're going to print out the distance, just the variable, so it doesn't need quotation marks. And we're going to go and we're going to round it to 2 decimal points, which is, you know, kind of what you want. You don't want it just to keep carrying on for a long time, but you also want to be somewhat precise. We're actually going to do another print here. And we're just going to print out the unit, because your cursor does move along while you type, kind of like it does just in a Word document. So this is just going to be at whatever the end of it is. And we're just going to print out a bunch of spaces like we did before. We're also going to put the unit here. So centimeters and then some spaces to cover up whatever excess is at the end, kind of like we did with the potentiometer. And this time we're going to add a slightly longer delay. We're going to add a 2-second delay, just to let whatever, you know, rays were bouncing around, you know, stop bouncing around. That way, next time we send out a pulse, we get an accurate reading. So now that our 2-second delay is in there, we're going to go ahead and we can save it and upload it. And if we look back, oh, that needs to be a capital I and pulse in, and you'll notice it actually turned the word orange. But now I compile the sketch and I upload it, and we take a look back at our coding array. You'll see that it says distance, and this is where it's measuring the distance from. So if I put my hand over it, the distance is only 5 centimeters. But if I remove my hand, it's casting all the way up to the ceiling, or it might actually be hitting the camera here that we're filming from. You'll notice that it's getting a distance of 170. Now, let's actually move it out from under the camera here. No, it's still getting about 170. So that's how you display distance using the ultrasonic sensor. On something like a robot, this could be useful for finding the distance to like the nearest wall, or so that way you can say if you get close to a wall, go ahead and turn the robot, or doing all sorts of things like finding objects, and I mean honestly whatever you need it to do. And so for the final bit, we're actually going to be measuring the temperature and humidity. This is the final project, which is why it was still on my screen when we first started. And we're going to keep the display. We're going to keep our LCD display, but we're going to go and we're going to swap out our ultrasonic sensor for a Dht sensor. So we need a few libraries for this. We're going to need Adafruit sensor library. And I hit caps lock halfway through that. There you go. For some reason, this one doesn't turn orange. It does work, though. This one does. And I think the reason for that, though, is if we go to Tools, or sorry, Sketch, and we look at our libraries, we look at the ones we've gone ahead, and if we look under Installed, and these are the three, you'll notice that like it's not technically called Adafruit Sensor or like Dht and whatnot, which is why I don't think it highlights it orange. But I mean, it doesn't give you an error if you run it, and it does work, so it's fine if it doesn't turn orange for you either. And the last one we're going to need is another Dht one. This is going to be Dht Unified. And now once you have your three things, we're going to go ahead and we're going to do something called defining. What defining does, actually, we should probably move these includes up to where our other ones are just for consistency's sake. There we go. And what defining is it creates something called a macro. And whereas a variable is kind of a copy-paste scenario, where if you went ahead and set, a pin to 5 and then you typed in the pin somewhere, like if you just typed in the name, it, sticks the 5 there. A macro is quite literally just copy-paste. So what you do is you give it a name, and we're going to give this one Dht pin, and the pin is going to be 12. Now, I could have just done this with a variable, say Dht pin is equal to 12, but this is more just to show you how a macro works. And we're going to go and we're going to do the type, and the type is actually a Dht11 sensor. Now, you'll notice that Dht11, I'm fairly certain that's actually another macro that's then actually built into our Dht sensors here. So we're just creating macros of macros, which, I mean, it works, so we're going to go with it. This time, we're going to create an object of type Dht Unified. I'm going to call it Dht, similarly to how we made our LCD variable up top. So Dht here is going to be it's going to take a pin, which is Dht pin, because we define that with our macro, and it's going to take a type, which we're just going to type Dht type. And all should now be working to set up the Dht sensor. Excuse me. The next thing we're going to go ahead and do is we're going to go ahead and we're going to print out some things. We're going to just type out temp. Type out temp here, and we're also going to type out humidity. Set this on the second line. There we go. So now that we're going ahead and we're typing out temperature and humidity, we're going to go ahead and we're going to start our Dht sensor with a dht.begin. And now within our loop, we get to go ahead and add all of our Dht things. So we're going to get rid of all of this ultrasonic sensor whatnot that we were working on, and just leave the LCD part for displaying things. We can also just change our delay to 1000, just so that way it doesn't take as long between senses. And we're gonna do a variable of type sensors event t. And we're gonna call this one event. So now we have an object or a variable called event, and we're going to get the event of the Dht sensor. We're going to do dht.temperature, and we're going to do a .get event, and we need to pass in. We don't need to pass in event like the object, which I spelled wrong. We need to pass in, and caps lock. I hate caps lock. It gets me every time. We need to pass in what's called the address of it. So basically where it's stored on the computer. And you do that with this little ampersand, which is just the and sign, which is Shift 7 on your keyboard. So we're going to pass in the address of event, which is our variable. And then we're going to do our LCD here, where we're going to go ahead and we're going to set our cursor to set it to 60. So this is just how far along it is. The word temperature is 1, 2, 3, 4, 5. And then if you add like a space at the end there to go ahead and put a space there, that's 6 characters long. So we want to be 6 in before we start typing, so that way it appears right after the word temp. And this time, instead of typing out the distance, we're just going to type out event.temperature. And we're going to go ahead and we're going to round that to 0. And instead of printing out centimeter, we're just going to print out C for Celsius. Add some extra spaces to the end. And then we're going to do the same thing for humidity here. We've already created the variable called event, so we don't need to do that again. We just need this part. And instead of saying dht.temperature, we're going to say dht.humidity. And instead of going ahead and saying event.temperature, we're going to say event.humidity. But it's actually event.relative humidity is just what it's called. That's just the name of it. And it's not Celsius, which is going to be a percent sign. And it's all set up now. It should be good to go. Our loop has now been kind of finished. And what you'll notice, if we compile this, I think I may have spelled that wrong. Let's see here. Oh, sorry. It is DHT unified, but the library is just called DHTU. But then this is called DHT unified down here. I just got a bit confused. We are good now to go. And what happened here? Defines do not have the semicolon at the end, similarly to how includes don't. I don't know why I forgot that. And if we go ahead and we look back at our board here, you'll notice that it is saying the temperature. Actually, no, it's not doing that, because what I'm doing here is I never fixed my cursor, so it's just writing the humidity, the percentage, over top of it. Instead of being at 60, we want this to be at 10.1. And now, if we go and we compile this and look back at our board, this should fix the problem we were having. Now it is displaying the temperature and the humidity. And this is actually being detected by the Dht sensor, which is this blue sensor right here. And like, if you want to, like, temperature's probably not going to change. Maybe if I put my finger on it, it'll warm it up a bit. I mean, if I breathe on it, that'll up the humidity. Breathed on it, you can see it immediately went up to 95% humidity rather than like the 20-something it was at. And that should give you kind of the basic layout of how to use some of these sensors. A lot of other ones are similar. The touch sensor is just like a fancy button. You learned how to use your button. This is just an LED that can display multiple colors. You've got some more analog sensors over here, which you do very similarly to how you did the potentiometer. And you should be able to hopefully figure this out. And this should just give you some general kind of idea of how to do Arduino structure. That is going to be all from me today, guys. I hope you learned a lot, and I hope you guys have a nice day. Bye.